Awesome. Thank you. Welcome to Robots and Red Tape. I'm your host, Nick Shutt. I'm happy today to have Debbie Taylor Moore as my guest. She's a 22-year cybersecurity veteran who's worked as a practitioner, manager, founder, executive for some very large companies, a consultant, and an investor. She currently advises C-suites and executive boards on security at the intersection of AI, quantum, and robotics. She leads programs in government and industry in 25 countries across 4 continents. She's currently advising strategic clients, investors, and early stage companies in the areas of quantum resilience and resistance, or as the FedGov frames it, post quantum cryptographic migration and generative AI. Debbie, thank you so much for coming and hopping on to talk today.
Hey, Nick, it's great to be here. Thank you so much for having me.
Absolutely. So today we're talking all about quantum computing and post-quantum and the migration to post-quantum cryptographic cryptography and how important that is. So Debbie, if you don't mind, would you just talk a little bit about some of the biggest challenges organizations are facing in migrating to post-quantum cryptography, given, how quantum computers are continuing to grow and be a larger threat to the world at large?
Absolutely. So now we can't assume that everybody's heard about this necessarily. So let's assume that they haven't, but we'll spend just a little time talking
Mm,
about what it is that folks are most concerned about. So today, everywhere where all of us work, we are using classical computing. And quantum computing is a future. It's a future form of computing, but it's very different from classical computing, and classical computing is not going to go away.
mhm,
Quantum computing is just entirely otherworldly in its difference, in that when you think of quantum computing, think of its best use cases to be those areas where major computation is necessary. And that's where it's most helpful. But there are lots of today's problems that we think that we can solve with quantum computing in the future. And we're just trying to perfect it today and trying to, of course, nothing's perfect, but
mhm,
we're ultimately trying to make it usable to be able to solve a lot of issues within the realm of drug discovery, material sciences, supply chain complexity, anything that's really complex and involves computation, that's where you think about quantum computing. Now, that being said, quantum computing has a lot of promise, but it also has some peril. In the
mhm,
wrong hands, our current underlying encryption and our everything that our society relies on to keep secrets safe and keep our messages private, keep our text messages, our transactions, anything that we want to keep from prying eyes utilizes encryption. And that's sort of an encoding, decoding that happens within our within everything from our smartphone to putting our identification card through our TCAC reader as we go into work to any sort of laptop, tablet. Encryption's everywhere, particularly encryption that is asymmetric in nature is what quantum computing potentially undermine. It
mm,
could be so powerful that it could undermine encryption and lay all of our secrets bare, so to speak. And so this concern, I know you had another speaker on who did a beautiful job of walking through the sort of evolution of all of our concern around this, but
mm,
also the algorithms that sort of sit at the foundation of this. And so, without being repetitive to
mhm,
what he's already described, we can certainly have another conversation about that. But
mhm,
today, to answer your question, what are organizations concerned with? Organizations want to make sure that they are prepared, that essentially what we're talking about is a major migration. And so
mhm,
we've done this before. We've had over the years, encryption has become deprecated in that it's been compromised by some nefarious actor. And so everyone collectively agrees that we probably shouldn't use that encryption anymore and that we should upgrade to the next level of encryption.
Mhm.
And so that's usually something that's done, but takes a long time because of the pervasiveness of encryption in general. And it's usually done gradually over many years because folks don't want to break the current applications or run into difficulty when they go to move to an upgraded encryption.
Mhm.
So the idea of migrating to new encryption is twofold.
Mm.
There's the sort of the social aspect of it, but then there's the technical aspect of it. And so today we have a number of folks around the world who are primarily mathematicians who have
Mhm.
come forward with a number of algorithms that they believe are quantum resistant. And NIST, the National Institute of Standards and Technology, has been working since 2015 in order to actually vet these algorithms. They've done multiple rounds of vetting all around the world. Everyone has tried to cryptanalytically break the algorithms. And they've done so with simulations of quantum computing because we don't have a sufficiently capable quantum computer today,
Mm.
but we're working toward that, if that makes sense. And
Absolutely.
so I don't know, this might be a bit long, lengthy,
Please, please,
but
please. We're here to listen to you, Debbie. I wanna hear this is fascinating because, so like, when you think about and, for obviously, like, average people, right? We just folks like myself who like, I think I'm a little more technical than the average person, but most people, they don't understand what goes into, sending a secure message, or when you get on something like WhatsApp and they say it's, like, end-to-end encrypted. They have no idea what that even means, right? And they don't understand that, most of the internet's inaccessible unless you have the right password, right? From whether
Mhm.
it's your bank, you log it into your bank or your credit cards, or you go to your doctor and you log into your EHR portal and your health portal, right?
Right,
And they just
right.
assume that it's all fine and it's all locked down. But you and I both know that breaches happen all the time, constantly, right?
Absolutely.
I know people that are federal employees or government contractors or folks that have held clearances that are going to have, they have a lifelong subscription to Identity Lock by Norton, I think it is, forever because their information's been taken so many times by foreign actors overseas, right? And so
Right.
you start thinking about, a lot of I think, quantum is a little, it's still a little bit like sci-fi and that it's not quite here yet. We kind of know. So how do we know, how are we testing these algorithms in like, using simulations of quantum computing, and how are we able to know that these simulations are actually, actually real, right? And how do we know that it's actually modeling what quantum computing will actually be able to do?
Well, that's a great question because there are many companies that are working on what we call quantum tech. And so
Mhm.
there's quantum tech and there's quantum safe. And quantum tech is the area that is all around the development of hardware and software that
Mhm.
utilizes quantum physics.
Mhm.
And so when you ask your average person about quantum, they'll start to talk about how problems get solved in classical computing using, in a very binary fashion,
Mhm.
ones and zeros, and in a deductive fashion. Problems are solved after trying one direction or one path, another direction or path is taken. With quantum computing, you'll hear people talk a lot about superposition, meaning that something could be a one or a zero,
Mhm.
or a 1 and a 1, or a 0 and a 1, or many different, combinations all at once. And so
Mhm.
it's sort of like a mouse going down a maze where there's 500 options that it has to eliminate
Mhm.
before it goes on to the next one. And quantum, you have to think of it as just happening all at once.
Mhm.
All at once, it's trying every permutation. And so
Mhm.
there's a speed element, but there's also an element there's a speed element, but there's an element that is very tried and true and proven.
Mhm.
And so with quantum computing, what we see over and over again is that as folks sort of get to sandbox in these environments that have been created by all of the folks that are sort of at the top of the list of quantum tech that are investing in building out this technology. They're accessing it via the cloud.
Mhm.
There are simulators in place that allow them the compute power to challenge anything exponentially.
Mhm.
And that is how you will see quantum computing both now and in the future. Because in certain realms and certain manufacturers of quantum computing, it requires, because there's a physical aspect, it requires deep refrigeration.
Mhm.
And refrigeration so cold that it's actually colder than outer space.
Mhm.
These types of conditions in order to actually bring a quantum computer that is sufficiently capable. And I don't mean commercially available, I mean sufficiently capable.
Mhm.
And I think that there's a lot more detail involved in that probably left to a quantum tech discussion. But I will
Mhm.
tell you that this is the number one thing that creates challenges with quantum safe
Mhm.
because people are very, very interested in what's happening there. They're very, very interested in that piece. And the top question that I get all the time is, do I need a quantum computer in order to be quantum safe? And the answer is no, because
Mhm.
a adversary will find a way to break cryptography, and it'll be in a lab type setting. It'll be in a cloud type setting.
Mhm.
So it won't necessarily be a commercially available quantum computer. And most of us will never have in our lifetime quantum computers that are, on our desktop unless we're able to, manage refrigeration at 455 degrees below zero in our homes. So
Absolutely.
and that's some of the things that make it seem otherworldly. But I'll tell
Mhm.
you, the scientists that are developing quantum computing are extremely confident, and they've done more in the last 5 years to progress that technology than has happened in the last 30.
Wow.
And I've seen it firsthand with the scientists at IBM
Mhm.
how they operate almost as product development might, in
Mhm.
that usually you'll see research and development will have a set of stated goals, but there are different paths that are taken that will take you in so many different directions that it's very rare that they have milestones and they
Mhm.
hit each milestone. And that's what's been happening with the development of quantum computing, is that the milestones are being established and being hit regularly and consistently, and in some cases, much earlier than what was projected or anticipated. So that's why it becomes sort of a today challenge and a today issue that we need to think about. And so when you think of what it takes to actually upgrade encryption,
Mhm.
the challenges on the technical side that folks are most concerned with are really the complexity, not having enough resources,
Mhm.
but also visibility, like being able to see encryption across the board. It's very siloed within organizations, within systems, within departments, and in areas of responsibility. The other piece of it is that our heterogeneous environments, particularly distributed environments,
Mhm.
mean that we have a lot of third-party dependency. And so I could have my whole game together in terms of looking at an upgrade with just within, my enterprise,
Mhm.
if that were possible. But I'd
Mhm.
still have to involve third parties. I'd have to be concerned with what my cloud provider is doing, with what my major software providers are doing because of the interoperability
Mhm.
challenge. And so that technically complexity, the third party dependencies, and interoperability are probably the hardest parts of it.
Mhm.
On the more social side of it, it's the feeling about quantum tech, about quantum computing, the hardware software piece, and people feeling that not being able to grasp it makes it feel that it's very, very far away. And
Mhm.
in cybersecurity, we have so many upfront present operational challenges that we're focused on,
Mhm.
that it just seems like something that's very hard for people to walk and chew gum at the same time. But
One
mostly, the most important thing is that most cybersecurity departments operate as cost centers inside of organizations. And so in order to take on a new project that require quite a few more resources, but also some convincing and some major changes. You have to convince the folks who would offer the funding for that, that there is a true risk involved.
Mhm.
And what people face sometimes is, when they go to the top of the organization with this, is a lack of understanding
Mhm.
because there's confusion between quantum tech and quantum safe, but also apathy
Mhm.
around the uncertainty and uh, a desire to control the existing costs
Mhm.
of just, trying to manage the cost or lower the cost of operations as
Mhm.
it were. And so this seems like a new but nebulous thing. And a lot of times risk managers, people on the boards, people in the C-suite that manage risk
Mhm.
see this as more of a
Right.
long issue or
Mhm.
far away issue, but it is a long-term
Mhm.
project.
Absolutely. No, and it seems like and just out of curiosity, I know you mentioned that we've really accelerated over the last 5 years in this space, and I know is that related to AI, and is AI playing into how quickly this is going to continue to develop, and are those 2 interacting with each other or not in this way?
That's a good question because there is some use of AI to improve processes
Mhm.
that make some of the testing and evaluation faster
Okay.
than it would be otherwise. But I'm often asked the question about like, well, when once you mix quantum with AI, then where are we? And a lot of folks really have a hard time answering that question because we just don't know. It
Right.
could take us in a lot it could take us in a lot of directions, but yeah, it is being leveraged around processes. And
Okay.
I would say that one of the things that is kind of important aspect of this migration, just in
Mhm.
general, is the idea that so if you consider 2048-bit encryption
Mhm.
as the gold standard for what we have available today,
Mhm.
and you consider all the different permutations of 2048 digits um in as far as a key length is concerned.
Right.
A key length for a key length in a cipher block for the newer algorithms has got to
Mhm.
be more complex than that. And
Mhm.
so, considering that it's going to be lengthier, the cipher block sizes are going to be larger. They're not drop-in replacements for what we're using today with classical computing.
Right.
So they're actually quite a bit lengthier, which means that people have some concerns around potentially performance and reliability.
Mhm. Mhm.
So certain types of algorithms are going to be better in certain respects than others for certain types of things. And so when NIST release the standards, they're going to be coming out with three that will be focused. One will be like sort of general purpose, and
Mhm.
it's a key encapsulated mechanism um, algorithm. And then you'll have digital signature
Mhm.
algorithms. And it's those are sort of like what we're starting with. But you can assume two things. You could assume that in the quantum era, there's going to be more likelihood that we're not going to live with encryption for like 40 years the way we are able to do with classical computing today, but that'll
Mhm.
be frequently broken all the time. So we'll always need to have this constant pipeline of new algorithms. We
Mhm.
also need a really nimble and agile way to update because
Mhm.
this updating is sort of difficult because it's so manual. I mean, it
Mhm.
so involves testing because you're going from uh, one type of cryptography to another
Mhm.
that's somewhat multitudes beyond what we're using today, if that makes sense. And
Yeah,
so
it's
since
exactly.
it's not, drop-in
Mhm.
replacements, there's a lot of testing involved. And so that creates complexity and the length of time that
Mhm.
it takes because it's not all automated. But we want to get to the point where we're just automating all the time. We have visibility on all the encryption. We know
Mhm.
what's going on, and we're constantly able to make those changes and remediate quickly.
100%. And as you are speaking with the C-suite and the executive boards within organizations that you're consulting for, what are some of the top like 3 to 5 things that you're telling these people that they need to prioritize as they look at a PQC migration?
I think that the top things that they need to do is they need, first of all, some level of observability and visibility into what they have today.
Mhm,
So that is key. And so when you look at the federal government's been sort of driving the bus on this early because they've probably put in the most prescriptive set of instructions for agencies. And one of
mhm,
the first things that they wanted to do was to do what they would call a cryptographic inventory.
mhm,
Is somewhat difficult to do because encryption's everywhere. And in a lot of cases, it's in places where um, a lot of cases it's used. Sometimes it's custom, sometimes it's very old, sometimes there's just lots of surprises that are not known to folks when they go to try to gain visibility. And there are a number of great tools out there that help them to evaluate and assess their current environment. And so that's the first thing. The first thing is that they need some level of assessment, but they also need to prioritize because you're not going to wholesale migrate and change everything all at once. You want to change the most critical systems, which is a little different than the way we normally look at any sort of migration. We usually want to test on the low hanging fruit that's maybe easier and there's less risk. But in
mhm,
this case, because of the speed that's needed, you want to look at the systems that are most critical and start to sandbox with those.
mhm,
And so, and there's also, I think, an element of needing to understand from a resource standpoint who your key stakeholders are going to be and who's going to be involved in this process because it's not just the three PKI engineers that are down in the in the IT shop.
mhm,
There's going to be a lot of interaction between business system owners
mhm,
and IT and security
mhm,
because there are a lot of folks that are responsible and accountable. And so you need to establish almost little stakeholder council around this type of project.
mhm. Yeah, I would also assume that, thinking about from some of the worlds that I walk in, that it would bring a significant amount of staffing challenges from a workforce management perspective as well. Just
Mhm.
because I just did this is, not thoroughly researched, but I would guess that there's a very high barrier to entry to being able to work in this space and work on these systems in a way that, like, to your point about not to disparage any PI engineers, but it's easier to become one of them than it is to become an expert in this space, considering how cutting edge it is and the background knowledge involved.
I would say that there are not enough people that are aware of the challenge, and there is some oversimplification that happens in the industry.
Mhm,
Particularly, when I hear people call it like Y2Q or something like
mhm,
it Y2K. It couldn't be further from that actually, because it really, when you think about it, Y2K was a date certain, and it
mhm,
was literally a problem that was one dimensional. We knew we did not have enough characters.
mhm,
Uh, we didn't have not enough characters, but characters that went beyond 1999, and that they
mhm,
needed to be changed. It was a developer challenge more than anything, a code challenge. So this is quite a bit more complex, and I think that as people seek to learn about it, it can be a bit of a it can it can it can take over in terms of, like I said before, the quantum tech aspect of it
mhm,
versus quantum safe. If you think of it strictly in terms of migration,
mhm,
strictly in terms of cybersecurity, it's much more manageable. And I think also that, a lot of organizations use multiple vendors in this space today. And I think where some of the complexity comes in is when do you talk to all of them because they all are looking at this from a different angle,
mhm,
based on whatever it is that they have a specialty in. And
mhm,
so I think that that creates some challenges for folks because there's a big partner ecosystem. I mean,
Oh, yeah.
people that are just doing encryption services and managing certificates, and all they do is sort of
Mhm.
let the organization know when certificates are expired. You have
Right.
your cloud providers who have the developers who manage the CI/CD pipeline for all the organization's new applications, and they make encryption
Mhm.
decisions, that are cloud native. You
Mhm.
have, in manufacturing companies, you got robotic process automation where they've got, embedded systems and or IoT systems where there may not be enough compute space on an embedded physical system to manage a larger cipher block or a larger key. And so there may be some retrofitting that's necessary there. So it's a lot of different skill sets. You've
Mhm.
got, and depending on the vertical. So I always say that what's most important for these organizations is if you're like in the banking or financial services community, you need to get with your consortia that is focused on this problem.
Mhm.
If you are within telecom, there are groups within telecom that are really managing use cases, managing all kinds of testing of the existing algorithms that are, the final candidates.
Mhm.
They've been doing testing for like a year and a half. And so, or 2 years since
Mhm.
2022. So I think it's important to have those discussions because you can, like a high tide can sort of lift all boats when you're in these groups. People learn from each other through this collaboration, and it's not the sort of thing that is like, "Oh, let me go consult a book or a white paper," because each organization situation is gonna be a little different. A lot of times it is, collaborating with these groups and getting deep in the weeds with them that'll help people with the education piece. But you have to free them up from a resource standpoint to really look at the best case and worst case scenarios inside the organization.
Yeah, no, absolutely. And I can imagine that, I know you mentioned a couple of industries. I can imagine that, things like your local power utility is going to be a big, big area for, yeah, they're going to need to do it. I know healthcare has to be thinking about this, absolutely. And then obviously in the government, I would assume some of the more critical systems or some of the national security related ones,
Mhm.
related ones, where we absolutely need to make sure that we're staying ahead and securing them first, right? Because some of the, and I like financial institutions absolutely need to be thinking about it. But, frankly, if you get some of my historical data of, what I was doing 5 years ago, that's less concerning
Yep.
than other areas. And I know, I touched on this, Chris and I touched on this when we spoke about how we need to be looking at, where's the most vulnerable information going to be 5 years from now, 10 years from now, and what matters most to a lot of this, to a lot of these industries, right?
Oh,
Um,
yeah. You're absolutely right. You bring up a really good point there because, say, for instance, you're looking at automotive, and sometimes cars, for instance, their designs are made like 14 years in advance. And so there's a bit of lock in that happens. But also, if someone wanted to steal their trade secrets or their design secrets, they could be very useful into the future. I think that obviously, as you have already stated, the intelligence agencies are most concerned because it's really ideally that it is very likely that they'll be far ahead of everyone in terms of you know establishing systems that are quantum resistant
mhm,
because they have to do that for national security, but also because those secrets could really be weaponized against the United States in a catastrophic way by our adversaries. And so those are also have a lot of value well into the future.
mhm,
Things like your social security number, your driver's license number are things that stick with you for life, but your credit card number, for instance, or any sort of transaction that you're doing today that's just a simple transaction is not considered long held
mhm,
information that can't just be replaced. And
100%.
so that and just avoiding the complete compromise of our telecommunications infrastructure,
Mhm,
kind of like way at the top. of importance. And
Mhm,
so, and I think everyone's sort of relying on those industries. I think it's interesting when you go and talk to people about this, the first response is usually some level of denial.
mm,
So the first thing is that, oh, it's usually, oh, quantum computers are 20 years away. I've read about this or read about that, and no one's going to build anything that's sufficiently capable to break encryption for 20 years.
mhm,
So I'll be retired in 5 years and or 4 years or whatever. So
mhm,
there's that kind of response. And then there's also the response that sort of transfers the risk. And many people at the C-suite and board level will say, well, we look at our top three vendors and we rely heavily on our cloud vendor. We rely heavily on our desktop and email vendor. And we know who these players are.
mhm,
And we just think that in the future, as we are adopting more and more cloud capability and migrating more and more systems to the cloud, that all that infrastructure will be owned by them. And they will have figured this out because they have to, because it's their core business. So
mhm,
that's another response. The other one is to wait on NIST. And everybody thinks of NIST as like having the Superman cape, and they are going to solve the problem. Surely someone has this, someone's got this. And I'll say they've done a terrific job.
mm,
But I do think that the only thing I think that organizations are realistic about is they don't want to go too far down the road with testing ahead of the standards being released. Like they
mhm,
feel like they need that justification to sort of begin the project. The issue and challenge is that everybody around the world is going to feel that same pressure. It's going to be a lot of media, a lot of press about this, and they're all going to try to run to the fire all at once. And there's just a finite number of companies engaged, a finite number of people with the expertise to actually run the projects, a finite number of products, which are sort of a patchwork quilt of products.
mhm,
And I think that they will find themselves having a little bit of FOMO, some fear of missing out, because they'll have to, they'll, their opportunity will come at a slower pace.
mhm. Absolutely. Yeah, I think FOMO becomes a big thing for everybody, and you only need to look at the last 3 years with, everybody hopping into generative AI space, and every you throw a stone, you can hit 4 companies that say they do generative AI now, whether they actually know what that even means or not, or
Hmm.
understand that there's more to AI than just the generative side, right? And that's just one piece of it. I think that, like, I was just at an event yesterday, and an expert was saying that he thinks that we're in a bit of a marketing bubble when it comes to generative AI. And so I think that you're absolutely right from a quantum resistant, migration. I think that it will all hit at once, and there's just not going to be enough, right? And it'll be interesting. How do you, so as a leader of leaders of organizations, how do you balance, that, and, also the concern of, putting resources into the wrong technologies or the wrong places where things could move and they could become irrelevant?
That's a great question because I would say that that's like the fourth problem, is that this is an investment for folks. It's not a cheap undertaking
Mhm,
because of the complexity, but it's because of the complexity and the length of time that it takes that you have to start somewhere. And
mhm,
just beginning is like a huge step.
absolutely.
And so what I would say in terms of balance is that if you run any of the today's current tools that really examine cryptographic systems inside the enterprise, you'll be stunned to see that not only do you not have the current um, cryptography systems that are pretty ubiquitous, like SHA-256, for instance, um, which is probably the most ubiquitous encryption schema. So when you think of that, and you'll find old stuff that's been deprecated a long time ago. I've never seen any of these assessments done, and there hasn't been just like, oh, a surprise, like, oh my
Mhm.
goodness, like I can't believe that old stuff's out there, or that we're still using this or that. So I would just say that there's a general hygiene that you can justify just to clean up today's environments without even thinking about the quantum resistant piece. Like just getting yourself ready
Yeah.
on that front. I would say 95% of organizations need to do that.
I Yeah, that makes a lot of sense. And I run a couple of smaller organizations, right? And I can tell you that I have multiple cloud providers. I have different email providers for a couple of them. I have
Mhm.
information in a bunch of different cloud storage places, right? We
Mhm.
have systems that we have, whether it's EHRs for medical records for patients we have, or resume databases, things like that. And those are, I mean, the resume stuff is relatively low, is relatively, low priority in my opinion. The health records are very high priority, right?
Mhm.
But I loved your point about how most people have no idea where all of their data is and how spread out a lot of it is. And you think it's all here because you hop on your computer and you're logging in, but you're really logging into servers all over the world.
Oh yeah,
Mm,
absolutely. And that's the scary part is the dependency. And so
mm,
some folks have complained who have sat down and they've sort of pulled together a group of stakeholders and they say, well, where are we at with this? Like, what do we know about our current just the enterprise, our enterprise. And they don't go 2 steps without having to start to realize that this is a third-party risk management project, that they have to call vendors and ask questions or have meetings or Zoom calls. And the vendors are invariably asking themselves the same questions. So the folks that the folks that they go to for the answers are asking the same questions, but there's something like 44 companies that are some of the usual suspects, all everybody you'd expect are part of this NIST Center of Excellence
mhm,
program that has been testing out the algorithms for the last 2 years. And they have signed a collaborative research and development agreement
mhm,
to take part in this. And they work with each other and they particularly work on easing the path of migration by learning certain things. And
mhm,
so what they've done is they've combined like you know, a classical algorithm along with a quantum resistant algorithm to create a hybrid. And in those cases, it's always stronger than the original classical
mhm,
uh, algorithm. And so they've done that and they've tested it for performance and reliability. And a lot of these players, some of them are really big cloud players, some of
mhm,
them are big network players and
mhm,
all that. And they share that data. And that data they have that data, but it's just that I would say most organizations, it's just not common knowledge across the org. There are
mhm,
select groups that are working on the problem, but that's the first step is to go and see what they have and what you can interact with. But some of the cloud providers, developers today can go out and try some of these quantum resistant algorithms and go out and include this in part of their, in their development of current applications. Some of the hardware providers are um, working with each other to be able to leverage quantum resistant algorithms on some of the smartphone providers, some of the hardware providers. Folks are working on things that are successful.
mhm,
And so they're building that path, but they're also building that expertise inside their organization as they go through
mhm,
all of this testing. And so there's a lot to leverage, but the beginning is everything. And it's not one guy or one department's job inside these organizations.
mhm,
In the federal government, they assigned a person, and this person was to be the migration lead. And
mhm,
they assigned it for all the civilian agencies, for instance. In some insurance companies and some banks, they have a person that's like the lead. But this person's job is to pull all the other stakeholders together. And
mhm,
none of this stuff happens, and you know this as someone who owns a company, unless the people at the very top make this a priority, it will never become one. And I think the folks at the very top, what they have to understand is that it's going to become a differentiator eventually. And so when I say differentiator, what I mean is a differentiator not just to their customers in that they choose one company over another because the company has and makes claims around being quantum safe. But also a differentiator when it comes down to compliance, regulatory, and insurance. When you start to get hit for various types of attacks,
Mhm.
you can expect that in the future. What work or what level of safeguarding you've done relative to quantum computing is going to be important to your insurance carrier, your insurance provider.
Mhm.
And so that's happening, and we see that happening with AI. It's the same for
Mhm.
this. It's the same.
Yeah,
Same concerns.
absolutely, and I'm sure people will get different rates based on that, and that's a real business savings, because I'm sure that, large companies have, let's just say, large insurance bills, and so,
I'm
you
not
know
laughing, but yeah, that
right.
part.
Absolutely, and, but, this, yeah, all this is amazing, but when you start thinking about, like, the end user and those of us that are not in the cybersecurity space, what are some of the societal and potentially economic impacts of a lot of, this migration, and what should we be thinking about? What should concern us?
Well, I think that for the end user, this migration should be happening in the background. So if it goes as planned, you shouldn't experience any latency, even though you're working with longer key lengths, larger
Mhm,
cipher blocks, and algorithms that theoretically um, require much more computation upfront with um, encryption and decryption.
mhm,
That should not be felt by the average, like by end users. Like all of it should be pretty unnoticeable to end users. You have to think to times when we've had to do emergency encryption upgrades in the past. I always think of some of the times when we've had to upgrade TLS, like when we had the heart. I don't know if you remember Heartbleed in 20, I think it was 2014, where it literally impacted like 25% of the world's servers. And it was an emergency upgrade that everybody remembers that worked back then because you basically had no sleep. You worked weekend on weekend. Like it was a process that had to happen quickly because there was a vulnerability that became a known vulnerability that everyone had to close or it would have been disastrous.
mhm,
Most of the time, our encryption has held up pretty well. If an adversary were to get involved, they would want to do a couple of things. They'd want to compromise our critical infrastructure, meaning turn off all the lights, turn off all the ATMs, poison the water, I mean,
mhm,
pretty catastrophic things that impact critical infrastructure. I
yeah,
mean, it could be, you know, a, uh, you know, a I don't want to say it could be a cyber war because in theory, we've been at cyber war for a really long time already. It's just
mhm,
never been called that.
mhm,
But it could be that's where it starts to hit the end users. Let's put it that way. If we don't do anything, that's when end users will be impacted.
mhm. No, that makes a lot of sense, and let's hope we don't find out, right? Because
Yeah.
I remember, Heartbleed a little bit. I'm certainly not a cybersecurity expert, but I remember, I think if I remember, it's like, didn't somebody like build a vulnerability in somewhere, and or is that a different one? I'm not 100% sure, but it was like in something pretty base that like some base code that everybody was using across like the industry everywhere. But let's hope we don't experience things like that at scale where people can just, turn off the power because that would not be good,
No, that would not be
to put
good.
it mildly. And then is there anything else that you think organizations should be thinking about or doing or kind of focusing on as we continue to move towards this?
I think they should pay attention, and I think that it's really important because quantum is such a complex discussion. They should use their words. Like I've tried to do here. I've tried to not use the buzzwords or the extremely technical words to describe um, what's in front of us. I think that's really important when the CISO or the CIO goes to the board to have a conversation about this, that they plain speak it in terms of its business impacts.
Mhm,
And so that would mean really just taking a couple of the key systems within the organization that bring the most revenue to the organization for an organization to have those systems disrupted means for them to not be able to run or
mhm,
operate or generate revenue or serve their client base or customer base or constituents, and put it in those stark terms. And storytelling is important here because when you say the word quantum, it sounds to people as though they need to make a big investment in a quantum computer
mhm,
or that they need to learn everything that there is to know about quantum technology in order to understand the problem. And neither of those two things are true. What you need to think of this in a more accessible way as an upgrade that is going to be long term, multi-year, an upgrade that's going to be somewhat complex and will involve mostly every bit of the enterprise systems and hardware and data center cloud everything
mhm,
but it's sweeping, but the important thing is that everybody's going to be in kind of in the same boat,
mhm,
all in this impacts everyone globally, and that it's in some ways I look at this as potentially a black swan event if one of the four nations that probably hates us the most gets a hold of it first
mhm,
or has the capability first, versus us just really having some awareness of the current environment and slowly working against a project plan that
mhm,
helps us knock down system by system in terms of priority and in terms of migration. Now, would also say that there are other mitigating strategies. People talk about air gapping certain systems or using data diodes in certain systems or QKD and segregating networks. And, like there's other mitigating responses to this, but you have to know your own environment, at least invest in what I would consider observability
mhm.
before all else. Because
Right.
you can't protect what you don't even know is there. And I would tell you that there is no one, no organization that wouldn't go out here and do an assessment, a cryptographic assessment, and not be surprised at what they find.
100%. I couldn't I believe you, which is why all these places keep getting hit with, like, ransomware attacks, other things, because people are able to get in, and if you had complete visibility into your cyber infrastructure, I would assume that would be a lot more difficult.
Yeah, I would say that. I would say that's absolutely true.
Yeah. Absolutely. Is there anything else anything else you wanna chat about? Anything else in closing you should think we should touch on here?
I would say that I know that there were you and I had a little bit of conversation about AI. And I
Mhm,
would say that there's three projects that sort of all, if you're efficient with the way you look at post-quantum cryptographic migration, you will look across your organization and you'll say to yourself, this generative AI thing, we sort of had to take these certain steps. We had to assess. We had
mhm,
to we had to like build a group of people that were stakeholders. We had to look at our current situation and against the pipeline of future things that we're trying to do. And we needed to have some visibility on the past in order to, go forward in the future. I would say that that is true for any of these zero trust initiatives that organizations have undertaken. I would say that that's true for AI, and I would say that that's true for quantum. And so this motion this assessment motion and this preparation motion should not be one that waits for regulatory, number one, because you could light three
Yeah.
before before regulatory ever really finds its way into being, at least here,
Mhm,
in North America. There's been a lot of work toward that, but I mean, in terms of seeing these areas included in audits. So
mhm,
so AI, any sort of zero trust initiative that involves identity and access management and is in place to shore up security programs And then the quantum piece is something that it's not that you have to look at all three of those things in silos. You actually could look at them collectively, and you would find some of the same stakeholders and some of the same processes that have to be put in place. Ultimately, what we're driving toward and what the future would look like would be crypto agility. And it would be a seamless, automated way of upgrading new encryption every time it gets hit in
Mhm,
the quantum era, being as unconcerned as we are today in that future era when you have um, a much more capable weapon aimed at you.
mhm,
So I think that it's a priority that should be prioritized along with the other things. The only major difference is that in organizations, realistically speaking, AI represents sort of a carrot, and quantum safe is kind of a stick.
mhm,
I say it's stick. I mean, you're safeguarding against harm, whereas AI has revenue potential, it's transformational in organizations, and it's more embraced. And it
mm,
also has come about, particularly generative AI since 2022, has come about at a time where it's been given far more attention for its positive effects and capabilities, and the ability to impact revenue in the short term.
mhm,
And so it's not a cost center exercise. It's more of a revenue generation exercise. And so you have the folks that are on the AI side, a lot of times it's the same groups of developers, data scientists, data engineers, and people who are shifting way left with AI, having to shift further left and include security in the inception and design phase
mhm,
of these AI driven applications. They need to be thinking that same way with the selections that they're making around encryption and not hard coding encryption into applications, which is not done all the time anyway with
mhm,
CI/CD pipelines and cloud native applications. But one thing is that's very, very different is that with the AI folks, I think the IBV, IBM's business value organization had done some studies and saw that 74% of organizations admitted that they didn't want to look backward on their existing implementations of AI for potential harm or potential bias or for explainability, like in the instance of where you were audited and you got
mhm,
to explain the intent of the model, explain um, what what went into establishing the code that built the application that leverages AI
mhm,
to what outcome. And so with quantum safe, that legacy environment stuff has to be cleaned up. You don't have the option. You got to clean it up because it leaves you vulnerable. And so in that way, it becomes a more all-encompassing project that people don't have the latitude to just say, whatever we built back then, we're just going to live with. We're going to just do this plan going forward.
mhm. Yeah, absolutely. Looking back, I would assume opens up uncomfortable liability questions that many organizations just don't want to open that box, right?
You're exactly right. You hit the nail on the head. Liability. And when you think about it, all of this really comes down to risk transfer.
Mhm,
And so when I mentioned earlier that for a lot of boards and C-suite folks who say, this is an infrastructure problem, and I see the cloud providers being the folks that are going to solve this and be responsible. It just means that instead of us taking all of this complexity in, we're just going to adopt cloud faster in
mhm.
order to avoid it. And I'm not saying that's not a strategy. I'm just saying that that's the way a lot of folks think about this.
It makes sense. No, and
Yeah.
it makes sense that you'd want to, obviously shifting responsibility is an answer. I
Hmm.
don't know if it's the best answer, but it's definitely an answer, right?
It's a
But
tactic.
yeah, absolutely. And you look at places like cloud providers, whether I mean the big ones, Amazon, Azure.
Mhm.
AWS, Azure, Google, and GCP, I think are kind of the three big dogs in the space.
Oh, yeah.
They have the budgets to afford these folks. They have, more of that, expertise in-house, and, to your point, it is their business, and so you'd think that they would absolutely have a lot in there and a lot
Yep.
is in that game, but I don't, I think always, it's incumbent on the end user to make sure that the systems that you're using are safe and secure, and you can't just shift that accountability off entirely, so.
Exactly, and there's never gonna be a complete transfer of risk, just like there's never gonna be a complete migration to the cloud, and
Mm,
so you're gonna be concerned with some level of on-premise, and I think that for large, governments like the US, a lot of, the important or critical systems that constituents touch
mhm,
are, on-premise, a good number of them, and when I
mm,
say good number, I mean like 70, 80%.
wow,
So it just depends on who you are, what vertical you're in, how you might need to approach this, but there are gonna be some that are gonna be a lot more, they're gonna have to apply a lot more urgency than others. And
mm,
I think that with federal government, they're trying to work hard to be an example for everyone else because, when you think about our critical infrastructure, it's like 90% owned and operated by private sector. And
mhm,
if you, the federal government, haven't employed this quantum resistant framework and a quantum resistant, post quantum cryptographic migration in place, you can't ask industry to volunteer without some level of roadmap because government can't enforce that. We can only encourage it.
mhm.
In the US, our government, unlike other governments where it can be enforced.
Awesome. I couldn't agree more. And Debbie, I just want to say thank you so much for coming on Robots and Red Tape today. It's been so much fun to have you. I've really enjoyed our conversation. I always appreciate how you're able to take things that are incredibly complex and make them digestible and palatable. So thank you so much. It's been a lot of fun.
It's been a lot of fun. It can be a dry topic, but it's a lot of fireworks if we don't get what we need to get done.
100%.
That's for sure.
Debbie,
So hopefully people take it seriously.
I know you're out here doing the good work, trying to make them understand the potential consequences of not doing it. So, Debbie, thank you again. I'm Nick Shutt. Appreciate you guys coming and listening to us today.